Hello, Algebra 2. Welcome to day one of the virtual learning. Today we are going to talk about the graphing of polynomials as continuations from yesterday. I gave you several problems to do for multiplicities and finding zeros and things like that. For yesterday's homework, don't worry about it because it was not an electronic submission. And today is like the first official day where everyone should be on the right page by doing the online submissions, and I'm hoping and expecting everyone's assignments to be turned in on time. I want to start us off with just a bit of an earlier notes, and then I'm going to go into dive into the depths of the multiplicities, and then whatever the homework that comes out, it will be related to the lesson that I'm providing for you here. It's going to be very quick. So for those of you guys that were here yesterday, we talked about how we're finding the zeros for these two particular problems of finding the zeros, end behaviors, and the leading term. Yesterday, we talked about how these three parentheses, they just end up giving you a zero at -3, -2, and +1. End behaviors are dictated by what the leading term will be. In this case, it will be -x to the power of 3. You have to take the sign and the x's in each of those parentheses, multiply them out, and the very first term you will get is -x to the power of 3, and then there will be subsequent terms following after. But like we have talked about before, we really don't care about all the rest of the part of the polynomials because it's not really relevant to finding the end behaviors. Now, if I know that, going back to the notes that we had here, if I know my degree is odd, it has to be one of these two, and my coefficient is negative, so we're looking at an end behavior situation number 4. This is how I can determine which one I'm looking at. So going back to this, I know my end behavior has to be up and then down, or x approaches -infinity, y approaches +infinity. As x approaches +infinity, y approaches -infinity. And then the multiplicity here, you will say none because there simply is no multiple zeros happening. So you just simply plot them, -3, -2, and +1. And once that's done, you just have to correctly indicate where they would be by using the end behaviors. It starts from the top and it goes to the bottom. Then you connect those 3 zeros as such, and you will get that shape. Again, this is a sort of a review thing, so I'm going to move right along to the next one. This is an example of where you have a multiplicity. So you won't be able to write down none for any of these questions. You will say multiplicity of 2 at x equals 2. You have 2 twice. That's basically what it comes down to. So now the zeros will be at x equals 2 and at -3. The end behavior here, if you take a look, it's going to be x to the power of 3. That gives you x squared. There are 2 x's. There's one more x. Multiply them out, you get x to the power of 3. That end behavior goes like this. As x approaches -infinity, y approaches -infinity. As x approaches +infinity, y approaches +infinity. So we have that happening here. The leading term here will be x to the power of 3, and it's positive. And so all I'm going to do is I'm going to plot the 2, -3, start from the bottom. So now it's going to connect, but it's here because I have a multiplicity of 2. If you know from the previous what we talked about for multiplicity, if it's odd, it goes through, and if it's even, it bounces. So these are the shapes that I want you to keep in mind. Anytime we have a multiplicity of 2, it's going to bounce at that location. So then it's going to bounce at that location, and then it's going to go up, matching the end behavior on the right-hand side. Okay, so this was the review. Today, what I want to do is I want to talk to you guys more in detail about questions that looks like this. Your homework will be based on this, and plus we're going to go back and say, what is the possible ways in which you can write the equations based on the sketches. Okay, so we're going to be tackling on these questions as well. All right, so sketching polynomials for this. Let's say that I gave you a problem that looks like on the one on the left. Okay, now I know that I didn't provide for you the 4 essential things like zeros, leading term, end behaviors, and is there multiplicity or not. But you have to write that on your own. So here, let's say that you write the leading term, the end behavior, the zeros, and obviously the multiplicity. For the leading term, you just count out how many x's there are. So I have x times x to the power of 3 times another x. That gives me x to the power of 5th, because there are 5 x's in there. X plus 3, x plus 3, x plus 3, x minus 2. If rewriting it like that helps you, please do so. I can physically count just how many zeros there are. 1, 2, 3, 4, 5. There are 5 zeros. It's x to the power of 5. Now for the end behaviors, x to the 5th means that it's odd and it's positive. So I know, going back to our notes, as x approaches negative infinity, y approaches negative infinity. And x approaches positive infinity, y approaches positive infinity. So I can rewrite it like that. And then that's my end behaviors, or the arrow signs if you prefer. The zeros. Zeros happens at 0, because that still counts as one of the zeros there. That's at -3, and that's a +2. And so I am going to go to my graph, plot a 0, -3, and +2. Multiplicity. Do I see a multiplicity? Yes, I do. I have multiplicity of 3 at x equals -3. Now that's a new one because we haven't really tackled on x equals multiplicity of 3 before. But I know that at that specific location, it needs to do a little squiggly, and the shape will look like this. This is the shape that we're talking about. So what I'm going to do is I am going to go to here, and I'm going to sketch as such, going down, going up. That's the end behavior. So let's try to sketch this out. Ready? You don't necessarily have to start from here. I'm just going to start on my own like this. Do a little squiggly like that. So that shows the multiplicity of 3. It's got to go through it, but it can't go through like this. Like that can't happen. It's got to go through with a little curve. Then it's going to come down and then hit that 0. Then it's going to come back up and hit that 0. And those are just straight up no multiplicity, and then just goes straight through. So this is the shape that I'm looking at. I know it looks very weird, but if you type that into Desmos, I mean, you will see a similar shape that looks like that if you zoom out or zoom in, do whatever you need to do. All right, so what I would like for you guys to do is right now at this point, pause the video and try to see if you can do this on your own at your own time. And once you're ready, just replay back this video, and then we'll check our answers. Okay. All right. So I'm assuming that you guys have finished this, where I'm going to just write down LT, EB, zeros, and multiplicity. All right. So let's just talk about what these things should be. This, if you count the x's, that should be square, and that should be third, and there's one more x's in there. So that's x to the power of 6. It's an even powered function. So the end behaviors, even then it's odd coefficient, I mean even and a positive coefficient, means that there should be both going up like this. To give you guys a clarification, we're looking at a situation number 1. It's even and it's positive. Next, we are looking at the zeros. 0 happens at 1, 6, and -4. So I'm going to plot -4, plot +1, plot +6, and those are my zeros. Multiplicity, do I have them? Absolutely. I have x equals 1, or I have multiplicity of 2. It happens twice at x equals 1. It has a multiplicity of 3 at x equals 6. That's what I would say. And so I am going to plot them, but I'm going to emphasize the fact that this right here, it's times 3, multiplicity of 3, and this is times 2. So I know it has to bounce and has to go through with a little squiggly. So here's how I'm going to sketch it. I'm going to use a different color to indicate that. I start from the top, and it goes through that first point. There's no multiplicity at -4. Then I'm going to come back up, and it's going to hit this point, but it's going to have to bounce off at that location, hence multiplicity of 2. Then I'm going to come back down, come back up, because I'm going to hit that 0, up, squiggly, and then come back up, and it's going to match with the end behaviors that's both going up. I know it's weird, but the shape should not be any different from what you see on Desmos class, on Desmos, when you graph these things. So for today's homework, I'm going to give you guys these questions to do solely based on multiplicity. There should be a total of 6 questions like this. I'm sorry, 8 questions. You can find them on the slides as well, but I will make them as a PDF and you guys can make submissions through assignments. Okay, so this was a relatively quick lesson for today. So make sure you do this daily on a consistent basis. That's the main idea. I'll see you guys tomorrow with a different video on how to go from graph into equations.